Hey guys, welcome back to the channel. Today we're diving into a story that's reshaping the face of our planet, China's mega projects. From sky-high bridges that seem to float among the clouds, to tunnels carved through some of the deepest parts of the ocean, and giant dams powerful enough to light up entire cities, China is redefining what's possible in modern engineering. These projects aren't just massive in scale, they're built at a speed that leaves the rest of the world astonished. Behind them lies cutting-edge technology, relentless innovation, and a level of determination that borders on obsession. In just a few short years, China has accomplished what other nations might take decades to achieve. This isn't just construction, it's a national mission fueled by ambition, precision, and vision. But how did China make the impossible possible? What secrets lie behind these engineering miracles? Join us as we uncover the story behind China's most mind-blowing mega-projects. In the 21st century, China has emerged from the wounds of a century of humiliation, unveiling engineering marvels that astonish even the world's most developed nations. US President Donald Trump has publicly acknowledged that America could never compete with China's infrastructure, expressing amazement at China's highways, bridges, and cutting-edge projects. He has mentioned China many times in public and has repeatedly expressed how much he loves the country.
Let's say China. And you know China, 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 South China, China, China. People say, oh, you don't like China. I like China. China. I love China. China. China all the time. China. When was the last time you heard?
But the question is, do these praises truly reflect reality? Has China really surpassed the West in technological innovation? Or is it all an illusion created by spectacular appearances? As people often say, seeing is believing. First, we'll take you to witness how China, through incredible feats of engineering, has built the world's longest undersea tunnel. This is a story you absolutely won't want to miss. Among China's countless mega-projects that showcase its infrastructure prowess, the Shenzhen-Zhongshan Link stands out as truly exceptional. Its scale and ambition are unprecedented, and though still under construction, it is destined to become a historic milestone in engineering. Stretching 24 kilometers across the heart of the Guangdong, Hong Kong, Macau Greater Bay Area, this colossal project integrates bridges, artificial islands, an undersea tunnel, and the world's first underwater interchange system. It will not only dramatically shorten travel time between the major economic hubs of Shenzhen and Zhongshan, but also demonstrate China's world-leading innovation in infrastructure development. So how has China managed to sustain such massive investments in infrastructure and do so with remarkable efficiency and creativity? Let's begin with this extraordinary case. In its design concept, the Shenzhen-Zhongshan Link was created to ease congestion and build a direct connection between two powerhouse cities, Shenzhen and Zhongshan. Shenzhen, known as China's Silicon Valley, is a global technology hub and home to world-class giants like Huawei, Tencent, DJI, and BYD. From a humble fishing village, it has transformed into a modern metropolis of over 17 million people, leading China's charge in innovation and economic growth. Across the Pearl River estuary lies Zhongshan, one of China's key manufacturing and trade centers. Famous for its machinery, home appliances, and precision equipment industries, the city hosts more than 30,000 industrial enterprises. Yet despite their proximity, direct travel between Shenzhen and Zhongshan has long been a challenge, limited to the congested human bridge or slow ferry routes, often taking 2 to 3 hours each way. Once completed, the Shenzhen-Zhongshan Link will cut that travel time to just 30 minutes, a game changer that will dramatically boost logistics efficiency, reduce transportation costs, and reshape the entire Greater Bay Area's economic integration. This mega project is unprecedented in both scale and complexity. Stretching 24 kilometers across the Pearl River Delta, it includes a 17-kilometer bridge system, 2 artificial islands as transition hubs, and a 6.7-kilometer underwater tunnel, one of the world's longest and most advanced immersed tube tunnels. Its most groundbreaking feature is the underwater interchange system, allowing vehicles to switch lanes directly beneath the sea. A first in human engineering history. The tunnel consists of 32 massive prefabricated concrete segments, each weighing over 80,000 tons, precisely aligned and joined on the seabed with millimeter-level accuracy. To withstand typhoons, earthquakes, and powerful currents, the entire structure employs triple-layer protection, anti-seismic, pressure-resistant, and watertight technologies. The artificial islands serve as vital operational hubs, housing emergency response centers, toll stations, and logistics facilities, further enhancing the corridor's strategic importance. To protect the fragile Pearl River estuary ecosystem, the project also integrates extensive noise reduction materials and eco-friendly construction techniques, minimizing the impact on rare marine species, including the endangered Chinese white dolphin. All of this reflects China's mastery in modern engineering, a symbol not only of construction speed, but also of the nation's achievements in technology, sustainability, and urban planning. At the heart of this project lies a true technological marvel: the 6.8-kilometer-long underwater tunnel, reaching depths of up to 40 meters below sea level. Designed as a dual 8-lane passage, its transport capacity far exceeds that of the Hong Kong-Zhuhai-Macau Bridge tunnel section. To ensure airtight, watertight, and earthquake-resistant joints under such immense underwater pressure, engineers used high-precision steel gaskets and flexible sealing materials, achieving what they call a vacuum-grade seal at every segment connection. Each standard immersed tube section is 165 meters long, 46 meters wide, and 10.6 meters high. If you stood it upright, it would be the height of a 55-story building, built with nearly 10,000 tons of steel. Each section requires about 29,000 cubic meters of concrete, enough to fill 12 Olympic-sized swimming pools. An intelligent robotic concreting system featuring automatic cycling, autonomous movement, automated control, and high-speed pouring ensures both quality and efficiency. Once a tube section is completed in the factory, it is installed using an advanced floating dock alignment system, achieving a connection accuracy of less than 2 millimeters. Inside the tunnel, an intelligent monitoring and ventilation system continuously tracks CO2 and particulate levels. It features HEPA-grade filters, longitudinal airflow control, and adaptive LED lighting that automatically adjusts brightness based on driving speed and external light, reducing driver fatigue and the risk of accidents. To ensure the structure endures for over a century, engineers developed a 5-layer anti-corrosion system inspired by shark skin. It includes an epoxy waterproof layer, a polyurethane shock absorption layer, a ceramic nanowear-resistant layer, a hydrophobic fluoropolymer coating, and a self-healing nanofilm. Additionally, 552 sacrificial anodes made of zinc-aluminum alloy provide cathodic protection, actively attracting corrosive currents away from the main structure. The tunnel's exterior coating also features antibacterial and anti-fouling properties, preventing algae, barnacles, and microorganisms from attaching to its surface, keeping the tunnel clean and structurally stable beneath the sea. To achieve such extraordinary precision and durability, the entire manufacturing process took place inside China's self-developed AI Smart Dream Factory, a fully automated production base designed specifically for mega-scale infrastructure. In this climate-controlled facility, each 80,000-ton tunnel section is prefabricated with an accuracy within 0.02 millimeters, exceeding German industrial standards by 22%. Once completed, the massive segments are precisely moved by thousands of AI-controlled transport platforms, guided by GPS and laser navigation for exact positioning at sea. What once took 7 days of transport can now be completed in just 4 hours. Before installation, every single tunnel segment undergoes ultrasonic, X-ray, and magnetic field inspections to ensure there are no micro cracks or welding defects. Finally, the entire structure was subjected to extreme simulations, equivalent to 1,000 typhoons, magnitude 9 earthquakes, and even a projected sea level rise of 3 meters over the next century. The results showed its structural stability exceeded international standards by 83%. The Shenzhen-Zhongshan Link is more than just a tunnel. It stands as a symbol of China's engineering and technological prowess, a fusion of automation, artificial intelligence, and green construction. It connects not only two cities, but also China's bold ambition to shape the future. And as the final segment of the Shenzhen-Zhongshan Link locks into place, one thing becomes impossible to ignore. While the United States is still debating, China is still building. While Congress argues over budgets and repairs, China is cutting through oceans, mountains, and every limit engineering once had. This tunnel doesn't just connect two cities, it connects two eras. The era America used to lead, and the era China is defining now. Because when China decides to build, the world watches timelines collapse, records fall, and the impossible turn into daily routine. The Shenzhen-Zhongshan Link is more than an engineering victory. It's a message. The race is no longer about who started first, but who's still moving forward. So the real question is, as China keeps pushing the boundaries of speed, scale, and ambition, will the US catch up? Or is this the moment the balance of global infrastructure leadership quietly shifts? Once and for all? China is building some of the craziest, most mind-blowing mega projects on the entire planet. Not just bigger, not just faster, but so massive it feels unreal, so fast it feels impossible, and so precise it feels inhuman. We're talking about things like high-speed tunnels carved beneath the ocean, bridges suspended across vertical mountain cliffs, citywide power grids upgraded to sci-fi levels, high-speed rail that crosses the country at near airplane speed. And yes, every one of these projects is real. The first reaction from engineers around the world is, how is this even possible? The second reaction, if the US could do half of this, we'd call it a miracle. Today, we're taking you inside these jaw-dropping Chinese megaprojects to see how China turns something that should take 20 years into something finished in just 3. Are you ready? Because every single minute you're about to watch might make you rethink what humans are capable of. Let's begin. China's super projects start now. First up, an airport so massive, it looks like it was built for another planet. This is Beijing Daxing International Airport. You could run for 20 minutes and still not reach the other end. This isn't a terminal. This is a sci-fi megastructure with 5 runways, capable of swallowing 300 planes every hour. And the craziest part? It took them only 4 years to build the largest single-terminal airport on the planet. This isn't an airport. This is humanity peeking into the future. This is the world's most powerful hydropower station, and each turbine can light up an entire megacity. China built it inside a canyon so tight you'd think it was impossible, then installed the strongest hydro generators on Earth. Every drop of water gets squeezed for energy. And the power output? More than 10 nuclear reactors in the US combined. This isn't a dam. It's an electricity-producing monster. Imagine building a railway at 4,500 meters altitude, through frozen mountains, earthquake zones, landslides, and cliffs that look straight out of a video game. This isn't construction. This is a boss-level fight against nature. China is blasting tunnels through mountains, bridging bottomless valleys, and laying tracks where humans were never meant to stand. When this railway is finished, it will be one of the greatest engineering miracles ever attempted. China is literally turning the ocean into a superhighway. Look at this steel giant. Massive box girders lifted into the sky by cranes taller than skyscrapers. Every piece weighs more than a fully loaded Boeing 747. Typhoons, raging waves, nature throws everything it has. Engineers said, "We're not building a bridge. We're taking territory back from the ocean." And judging by the result, China is winning. These towers aren't power poles. They're the backbone of the world's strongest electric grid. China built an UHV network so powerful it can send electricity thousands of kilometers with almost no loss. American engineers saw it and said, "We can't even draw the blueprints for this." This is an energy highway connecting an entire nation at the speed of lightning. China built a bridge so long, it disappears over the horizon. 55 kilometers of steel and concrete cutting straight across the open ocean, with typhoon waves slamming against it every single year. And if that wasn't crazy enough, they also built a tunnel under the sea right in the middle of the bridge. Most countries wouldn't even attempt this. China? They just went and did it. This skyscraper doesn't just go up, it twists. The Shanghai Tower stands so tall, it creates its own weather at the top. Engineers designed it to survive typhoons by giving the entire building a massive aerodynamic twist. It's basically a tornado-proof skyscraper. And the elevators, they're the fastest on Earth.
各位来宾，欢迎光临上海之巅观光厅。Ladies and gentlemen, welcome to Shanghai Tower. 现在您所搭乘的电梯是目前世界上最快的超高速电梯。Now we are taking the world's fastest high-speed elevator. 电梯最快速度可达每秒18米。Fastest speed is 18 meters per second. 仅55秒便可到达上海之巅观光厅。In only 55 seconds, we will reach observatory of Shanghai Tower. 118层到了，祝您参观愉快。We have arrived at 118th floor. Wish you a pleasant tour.
This isn't an airport. It's a city controlled by AI. Robots handle luggage. Driverless shuttles move passengers. The runways operate like a perfectly timed machine. What exactly is an intelligent baggage transport system? And how does it operate? As an automated, intelligent, and unmanned end-to-end transportation solution, the Intelligent Baggage Transport System uses unmanned smart transport platforms together with a 5G-based integrated information processing system. Through fully autonomous driving, low-latency real-time monitoring, and fully automated task calculation and dispatching, it achieves unmanned, bidirectional baggage transport across the entire workflow, including aircraft arrival, baggage unloading, baggage transfer, real-time communication, integrated positioning, heterogeneous sensing, intelligent decision-making, and baggage loading. Typically, a complete intelligent baggage transport system includes an integrated information processing system, a smart transport platform system, and 5G network equipment. The integrated information processing system can connect to the flight management database and, with the help of edge computing servers, obtain real-time flight status. Based on inbound and outbound flight information, passenger baggage information, and VIP passenger information, it dynamically calculates scheduling tasks, generates task information streams, and dispatches them to the Intelligent Transport Platform. After receiving the scheduling tasks, the Intelligent Transport Platform is operated by ground service personnel. Following the manual driving workflow, staff complete baggage loading and then switch the platform into autonomous driving mode. While autonomously transporting the baggage to the designated loading station in the baggage hall, the system simultaneously notifies technical staff through a task terminal to manually complete baggage unloading. After unloading, the baggage is sorted accurately with the cooperation of computer vision and automated robotic arms, directing items onto different conveyor belts or pipelines, transferring them to the appropriate baggage carousels, and feeding back the entire task completion process to the airport and ground service teams through the system. Of course, as one of the essential conditions for stable operation of the Intelligent Baggage Transport System, the 5G network also plays a crucial role. With its low latency and large bandwidth, 5G enables real-time video monitoring, dynamic vehicle data broadcasting, and task status inquiries between the Integrated Information Processing System and the Intelligent Transport Platform. It also enables remote control of unmanned vehicles through a remote console, achieving remote, centralized, and collaborative task management across different job roles and task types. Meanwhile, during autonomous driving, the Intelligent Transport Platform uses 5G's low-latency capability together with UWB-assisted positioning stations to continuously calibrate its coordinates and heading. It also employs laser slam technology fused with GPS, IMU, and wheel speed data to overcome the limitations of satellite positioning in tunnels, indoor spaces, or other environments with overhead obstructions. This enables centimeter-level real-time positioning throughout the entire area. Using LiDAR, millimeter wave radar, and vision cameras as its sensing system, it provides the decision-making module, the vehicle's brain, with a complete, semantically rich 3D environmental model. With this decision-making brain, the vehicle is capable of autonomous obstacle avoidance, mixed traffic lane changing with both people and vehicles, cross-lane turning maneuvers, as well as human-like intelligent behaviors such as trajectory planning and following the vehicle ahead. China didn't just build an airport, they built the world's first fully intelligent aviation hub. This is the world's biggest automated port. No drivers, no forklifts, just an army of robots loading and unloading the biggest ships on Earth with laser precision. This port moves more cargo than most countries do in an entire year. This isn't shipping, it's science fiction running on electricity. The underground supercity. China is building subway lines faster than most countries can build a single station. They drill tunnels under ancient buildings, under rivers, under living neighborhoods, all without shutting the city down. Every year, dozens of new lines open, At this point, China's building an entirely new city beneath the old one. Imagine building a brand new city from the ground up, with underground highways, robotic delivery systems, and zero pollution zones. That's Zhong'an. China isn't upgrading a city, they're creating the prototype of future cities, China's mega-solar deserts, the sun factories. These are not sand dunes. These are endless solar farms stretching across the desert for miles. Huge arrays that power entire provinces, so massive they can even modulate the local climate. This is what happens when renewable energy isn't just built, it's engineered at a planetary scale. And that was only 12 of them. 12 mega projects so massive, so advanced, and so unbelievably fast to build that they're forcing the entire world to rethink what is actually possible. From the world's largest airports to hydropower monsters buried in mountain canyons, from railways carved through frozen peaks to sea-crossing bridges that rewrite physics, from AI-powered airports to robot-run superports to cities and power grids straight out of science fiction. China isn't just building infrastructure. China is building the future. Piece by piece, turbine by turbine, tower by tower. Every one of these 12 mega projects proves the same thing. Impossible is just a word, and somebody somewhere is already proving it wrong. So after seeing just 12 examples of what engineering looks like when nothing is off limits, you have to wonder, what will the next decade look like? What happens when this level of ambition keeps going? And how far can human ability really go when a nation decides to aim for the extraordinary? Imagine a 24-kilometer highway that slices through the sea, combining bridges, artificial islands, and a 5-kilometer underwater tunnel. This is the Shenzhen-Zhongshan Link, a masterpiece of daring engineering. Over 4,500 massive cargo ships pass through its shipping channels every day, yet traffic is never interrupted. Engineers didn't just build a bridge or a tunnel. They created a seamless connection beneath the waves. Steel, concrete, and precision engineering work together to conquer nature. This is more than infrastructure. It's the underwater highway that turns impossible into reality. Dalian Bay isn't friendly. Winters plunge to minus 22 degrees Celsius, threatening concrete curing. Yet China built its first cross-sea immersed tube tunnel in the freezing north. 3 kilometers of massive concrete boxes. Each immersed tube section is 165 meters long, 46 meters wide, and 10.6 meters high. If stood upright, it would be equivalent to a 55-meter tall building. Engineers floated them into place, sank them into the seabed trench, and pumped out the water to form a continuous roadway. This is not just construction. This is a battle with the elements, solved with innovation, precision, and relentless speed. An hour-long detour, now just 5 minutes through the tunnel. And just when you think that's unbelievable, China goes even deeper. 78 meters beneath the sea, under crushing water pressure, engineers are now boring a tunnel for high-speed trains at full speed. Meet the Gintong Undersea Tunnel, 16 kilometers long, with 11 kilometers running nonstop beneath the seabed. This is no longer transportation. This is humanity drilling straight through the planet. Every segment must withstand 7.8 atmospheres of pressure. One mistake could be catastrophic. 2 gigantic tunnel-boring machines, guided by lasers and satellites, carved through rock with millimeter precision. This is not just a tunnel. It's humanity rewriting the rules of engineering under the ocean. But China doesn't stop there, because the next tunnel isn't for trains at all. Welcome to the Yellow River Tunnel, the gigantic highway tube, not for rail, for cars, 17.5 meters in diameter, double-decker, 6 full lanes of non-stop traffic, rushing through the riverbed itself. China drilled through the Yellow River bed at record speed, 16 meters per day. The secret? A custom-built machine named Shanhe, devouring soft soil, installing concrete segments simultaneously. Incredible speed, extreme precision, and unfathomable scale. This tunnel transforms a massive river barrier into a 24/7 superhighway. This is the gigantic highway tube, where size, speed, and engineering collide. But China's engineering defiance of nature doesn't stop underground. Now, it goes vertical. Welcome to a battle between gravity and human ingenuity. The Three Gorges Dam ship lift, 3,000 tons, lifted 113 meters into the sky in just 40 minutes. No engines pushing it upward, only gravity, buoyancy, and pure mechanical genius. It's like stacking 30-story skyscrapers vertically and moving them in a single ride. Every mechanism is engineered to perfection. Every drop of water is harnessed. This is not a lock or a canal. This is the ultimate marriage of physics and human ingenuity. The ship lift shows what happens when you turn natural forces into precise engineering magic. But China didn't stop at lifting ships through mountains. Next, it lifted a bridge into the clouds, 625 meters above the river, nearly double the height of the Eiffel Tower. This is the Huazhong Grand Canyon Bridge. Steel and concrete stretch across a bottomless gorge in Guizhou, suspended in thin air, defying gravity, cross winds, and raw geological chaos. Cars don't just cross a river here, they drive through the sky. This is not a bridge. This is a ribbon of steel stitched into the clouds. Engineers battled earthquakes, typhoons, and steep cliffs to create this sky ribbon. It's not just a bridge, it's a lifeline, transforming a dangerous mountain trek into a 2-minute drive. Every glance down is breathtaking. This is the sky ribbon. Beauty and engineering fused. But the sky isn't finished yet. 3 megatowers rise into the clouds. The tallest one reaches 332 meters, higher than the Eiffel Tower. This is the Ping-Tang Bridge. From a distance, its structure bends light, shape, and perspective, forming a perfect halo in the mountains. They call it the cosmic eye. And it's not art, it's a bridge. Engineers had to stabilize foundations on karst limestone, navigate underground voids, and resist fierce winds. It's a bridge, yes, but also a piece of art. Functional, monumental, and visually hypnotic. The cosmic eye isn't just engineering, it's a vision turned reality. And just when you think bridge design can't get any crazier, China builds one that carries 3 worlds at once. High-speed rail, city traffic, and a full-scale expressway. This is the Changtai Yangtze River Bridge, the triple transport monster, a single structure carrying 3 different transportation systems simultaneously. And with this 3-in-1 design, an 80-minute journey between cities is crushed down to just 20 minutes. 3 layers of motion, 1 unstoppable river crossing. This is not just a bridge. This is transportation stacked in 3 dimensions. Asymmetrical decks, diamond-shaped towers, and multi-load balancing, all engineered to perfection. It's not just a bridge, it's a transport revolution, connecting communities and rewriting regional mobility. This is the triple transport monster of the Yangtze. And just when you think China's bridges have reached their limit, it builds one that dares the open sea, 35.7 kilometers across the Hangzhou Bay, one of the longest sea-crossing bridges on Earth, directly exposed to the fiercest typhoons in China. This is the Hangzhou Bay Bridge. Here, hurricane-force winds slam into the structure, walls of seawater crash against it day after day. So engineers turn the bridge itself into a living structure. The massive concrete piers are designed to withstand hurricane-level waves. And the bridge deck? It doesn't fight the storm, it flexes with it, absorbing the violence of wind and water like a living spine. This isn't just concrete and steel anymore. This is engineering that bends, breathes, and survives the ocean. And when the sea itself becomes the battlefield, China doesn't retreat, it builds power stations on the water. Hainan Offshore Wind Farm. Hundreds of floating turbines rising from the South China Sea, some towering over 200 meters tall. These aren't just windmills, they're power factories, generating electricity for millions of homes. Engineers battled super typhoons, crushing deep-sea currents, and the relentless corrosion of salt water to anchor these modern leviathans. This is renewable energy on a scale that feels impossible, but China did it. The ocean turbines show what happens when energy, scale, and daring collide. And from the open sea, the challenge shifts to something even more vertical. Chongqing Monorail. Suspended over steep canyons and threading through dense city streets, this monorail climbs hills at impossible angles. Curves, tunnels, and bridges twist through the skyline like a steel roller coaster. Every day, it carries hundreds of thousands of passengers, connecting neighborhoods where roads could never exist. The mountain climber proves that urban mobility can defy gravity, terrain, and expectation. And just when you think engineering can't climb any higher, it goes into the sky itself. Tibet Ngari Airport, the sky-high runway. At 4,274 meters above sea level, Ngari Airport is one of the highest airports on Earth. Engineers fought extreme altitude, freezing temperatures, and thin oxygen-starved air to lay a runway capable of handling full-size jet aircraft. Up here, engines lose power, human lungs struggle to breathe, and every single takeoff becomes a precision duel with physics. This is more than an airport. This is where engineering reaches into the clouds. The sky-high runway stretches human possibility to its absolute limit. And while some of China's boldest engineering reaches upward into the sky, another silent giant is being laid deep beneath the ocean. Under the South China Sea, a massive subsea fiber optic cable stretches hundreds of kilometers, connecting millions of users to the digital world in milliseconds. No planes, no bridges, just pure information, racing through the darkness at nearly the speed of light. China didn't stop there. It built mega data centers alongside it, each the size of a skyscraper, packed with servers, cooling systems, and AI infrastructure. This is where the internet meets engineering on a planetary scale. Every email, every video call, every online game could pass through this cable. It's not just infrastructure, it's the digital nervous system of a nation, built like a sci-fi fortress under the ocean. The internet backbone proves that China doesn't just connect cities, it connects the future. And there you have it, China's most insane jaw-dropping mega projects, each one bigger, faster, or wilder than anything you've ever imagined. From tunnels under the ocean to bridges that defy gravity, from airports that feel like spaceships to entire cities built from scratch, from energy grids that light up nations to robots running the world's biggest ports. These aren't just feats of engineering, they are a statement, a reminder that when humans push the limits, the impossible becomes reality. So the next time you think a project is too big, too crazy, or too dangerous, remember this: somewhere in China, engineers are already building it, bigger, faster, and more precise than anyone thought possible. If this blew your mind, smash that like button, subscribe for more insane engineering, and drop a comment. Which one of these mega projects would you want to see in person? Thanks for watching, and remember, the world is way bigger, faster, and wilder than you think. See you next video.